Yes, this is lecture number 3, derivatives and integrals involving the natural log function. Okay, so f of x is the natural log of 3x squared plus 2x plus 1. And what is the derivative? Or conversely, if we have, what is the antiderivative of 3x 3x plus 1 over 3x squared plus 2x plus 1 dx. So here's a couple of problems, and you're asked to find the derivative and the antiderivative. This one is obviously involving the natural log because it has natural log. So let's look at the derivative rules first. The derivative with respect to x of the natural log of u is going to be 1 over u, and then use the chain rule, du dx. Okay, so dealing with this one, you can easily write down 1 over u, 3x squared plus 2x plus 1, and then follow that by the derivative of 3x squared plus 2x plus 1, which would be 6x plus 2. And you'd be done. There's no simplification that goes on. You're finished with that problem. Now, let's look at the antiderivative. The antiderivative formula involving natural logs is this. The antiderivative of 1 over u du is going to be the natural log of the absolute value of u. Okay, so that's going to be important. Natural log of the absolute value of u. And in this problem, we have a fractional rational expression. And what you should probably do when you see these is try to shoehorn it into this idea, 1 over u du. Because if you can, then you'll get the natural log. So I'm going to write this as 1 over 3x squared plus 2x plus 1. And I'll put the 3x plus 1 off to the side with the dx. So basically taking this and moving it at the back, so I have 1 over u. Now, do I have 1 over u du? And you should be pretty clear that you don't. This is my u term. And so just off to the side, u is 3x squared plus 2x plus 1. The derivative would be 6x plus 2 dx. And I don't have 6x plus 2. Okay, but looking at my problem, I do have 3x plus 1. And if you compare this with what you need, you say, ooh, all we're doing is missing a factor of 2, which we're allowed to put in. So I'll put a 2 in and a 1/2 here. Okay, so now my problem does match up this pattern, right? I have 1 over u, here's my u, and I have the correct du, which is 6x plus 2 dx. So now I can go ahead and write the answer. And here's the answer, 1/2 times the natural log of the absolute value of 3x squared plus 2x plus 1. Okay. So not too bad there, yeah, plus a constant. Let's look at another one of those. These come into play a lot with trig functions. So if I said, what's the antiderivative of the tangent function, dx, and you go, well, that's a trig problem, that's not a log problem. Wrong-o, it is a log problem. Okay, so I'm going to write this as the sine of x over the cosine of x. So now I see my rational form. And then I'm going to write that as 1 over the cosine of x and move the sine of x off to the side, just like I did on the previous problem. And then I'm going to try to see whether or not I have 1 over u du. Because if I do, then I'll have the natural log absolute u. Okay, so for this problem, the u is the cosine of x, and the derivative of that the derivative of u with respect to x would be negative sine of x. Usually we skip that step. So du is negative sine of x dx. Okay, so that's what I need. In this problem, I need a negative sine of x dx, and I don't have that, but I can multiply by negative 1, okay, and multiply by negative 1 here. So those balance each other. So now I have 1 over u Here's my u. I have the correct du, negative sine x dx. So I can now write the answer as negative from here, this negative 1, natural log, absolute value, cosine of x, plus a constant. And so there's another natural log form. Again, you don't see a natural log in the problem. You saw a trig function, but it does work as a natural log. Okay? And let's do one more just for practice. Suppose I asked you what is the antiderivative of 2x over x squared plus 9. Okay, so hopefully you can look at this and yeah, it's just the natural log, right? Because you have, this is the correct du. So it's the natural log of x squared plus 9 plus a constant. Notice no absolute values because we do know x squared plus 9 is positive. It wouldn't be technically wrong to write it this way, but you would never see that in May. If this were a multiple choice test, no questions would have absolute values around x squared plus 9. Question. If I do a multiple choice, I'm not going to have that. It won't be a free response. It'll be a multiple choice. You won't see it there. Or maybe it'd be a true-false question. True-false. This antiderivative must include the absolute value of x squared plus 9. True or false? False. It doesn't have to include the absolute value of x squared plus 9. Right? Okay. Now, let me tweak this problem one more time so that we have the antiderivative of 2x plus 1 over x squared plus 9. This is one that we saw on a quiz the other day. So you think, yeah, we separate this into two different integrals, 2x over x squared plus 9 dx, which we already know, and the second one would be 1 over x squared plus 9 dx, and you should know that as well. That's your arctangent. Okay, so we have the natural log of x squared plus 9 from the first bit, and this is 1/3 the arctangent of x over 3 plus a constant. Now this is from a previous chapter, so probably not on this chapter test, but certainly on the exam, right? Because the exam has got to cover everything for the entire semester. This would be the test problem. Test. Okay, so let me go ahead and stop that there. And the last thing we need to do is L'Hopital, and we're going to run out of time. So